So, welcome back everybody. Let me introduce you to Tenev from Storpool, and he's going to talk about the snapshot copy feature. Round of applause.
So, hello everyone. I'm Nikolay Tenev and I'm Solutions Architect in Storpool. And I think that is enough for me, so go further. The topic for today, the most important topic for next minutes, is a snapshot copy using a primary storage. But in the beginning, I will share a few words about our company, because this is talk from our company, this is not my personal topic, and just to give you an idea from what position we are talking. Storpool is a primary storage platform for CloudStack, and up here you can see a few statements that we firmly stand behind. See, software-only solution made for large-scale, modern IT, ultimate performance, so on and so on. The idea here is that we are, as a company, understand the modern storage system and the solutions that such a system must provide. So, again, step back. The topic for this session, snapshot copy using the primary storage. And let's see what we have today. From 4.19 version, CloudStack implemented a new feature, snapshot copy, which allows the system administrator operators to copy snapshot from one zone to another, which usually means different physical location. And this is great, very great, because this open, how to say, different and flexible DR setups. You can say these snapshots go to the zone A, these snapshots go to the zone B, this group of snapshots can be cloned in both zones, and so on, so on. You can imagine it. You can do scenarios like hourly backups in Europe, daily backups in USA, weekly backups in India, Japan, somewhere. This is a very flexible, this feature allows very flexibility. Also, easy migration. If you have a staging environment where you are sure that your product is already working, you just can clone it in the different location around the world, just a few clicks. It's many other scenarios that you can just imagine. Still, there is one inconvenience. The snapshots are created on the secondary storage, which is most probably network file system, NFS. And after they are created on the secondary storage system, after that they are transported to the remote secondary storage. It works, it definitely works, it works well, but the operators need to keep in mind some disadvantages. Creating snapshots on the secondary storage means that you using most probably network file system, which is the network file system architecture is layer over layer over layer, which means local hard drive, some storage drive, local file system, network protocol, shared file system. So many levels, they works, but could not be the optimal solution for your use case. Workloads, when you create a snapshot and transport it, are handled by the system virtual machines, with all limitations of the virtual machines. Virtual CPU, dedicated amount of RAM, virtual block, virtual SCSI, virtual net drivers with all their limitations. Yes, it works if you must transport 5, 10, 15 snapshots, but what about if you need to move 100 snapshots hourly to the remote location? This means 100 virtual machines. And last but not least, additional virtual drive conversion. Usually the primary storage system, you provide the volumes as raw block devices or LVM volumes or ZFS volumes to the virtual machine. When you want to copy snapshot to the secondary storage system, it must be converted to a QCOW image, which is additional process, additional conversion. And then when you move the snapshot to the remote secondary storage, you want to use it, you must convert it back from QCOW format to the format that primary storage use on the remote location. Again, this definitely work, but what about if your primary storage already can create snapshots. Your primary storage solution already know how to create the snapshots. Your primary storage solution can create incremental snapshots. So each snapshot contains only the changes from the previous, no all information that is to the current moment. Also, your primary storage can send these snapshots to the remote location using their internal tools and features without using external softwares. And last, when your primary storage know how to create snapshots, usually this primary storage create these snapshots in a format that is native for that primary solution. There is no need to, again, convert it from one format to other format, third format. So, if your primary storage can do that, why not use them? For the upcoming version of CloudStack 4.21, there is a push request with this number 9478, which implements an enhancement this function to copy snapshot using store pool as a primary storage to a different zone, only between primary storage. And the good news here, if you scroll down in this GitHub page, this feature is not limited only to the store pool based primary storage. This is an API enhancement and allowing each primary storage provider to adopt this functionality by the primary storage should have the functionality can copy snapshot between zones. The respective plugin needs to implement the copy snapshot method in their snapshot strategy, and the driver can handle the copy operation. And for this free, please don't ask me, they come to me from our developers, I don't understand them. So, what all that means? How our PR changes the things? What is the difference between CloudStack 4.19 versus CloudStack 4.21 with our PR? Again, in 4.19 version, the operators had the options to have their CloudStack environment with some virtual machines, with their virtual drives on the primary storage, and then they can create snapshots on primary storage and copy this snapshot on the secondary storage. And this, with the new feature copy snapshot, through the network, the administrators can send these snapshots to a remote secondary storage. That's nice. And then, if they need, they can use these snapshots as a volumes, as a virtual machine, disaster recovery scenario, so on and so on. In the future 4.21 version, there is a new field that named storage pools. And instead of only remote zone, the administrators already can choose in the remote primary storage. So this opens a path to additional scenarios. First, the important. Yeah, first and the important, this PR doesn't break the current behavior. Something new doesn't break something that's already working. So the default behavior of transporting the snapshots between secondary storages is keep it untouchable. The second scenario, if the operator chooses only the remote storage pool, again, it will be created snapshot on the primary storage. This snapshot will be copied to the secondary storage, but with this new feature, the snapshot from the primary storage through the implemented function of the primary storage will be transported to the remote primary storage without additional conversions and moving. This is one option. The second one is when the operators choose end secondary zone primary storage. And because this is the end, the administrators can select multiple secondary zones, multiple primary storage and secondary zones. And this combined behavior of previous two scenarios, again, what we expect, local storage, local snapshot, secondary storage, network move, and simultaneously the snapshot from the primary storage is moved to the removed primary storage. What are the benefits for such an option for you as a user, for us, not only you? Copy the snapshots directly between primary storages can scale better. There are no need of additional virtual machines, additional system VMs. You use the resources of the primary storage. In case of disaster recovery, because the snapshots is in the native format of the remote primary storage, the time to convert them to usable volumes will be significantly shorter. And additional DR scenarios when you can disperse the snapshot between different locations. In this location be only snapshots in the primary zone, in this location will be snapshots in the secondary zone, in other zones both storages. So yeah, different scenarios. And that's all. Questions? No, thank you.
Well, I have a question. So you mentioned this is not just store pool, but also runs on other type of storages. So probably not, but can you copy a snapshot from, let's say, NFS to store pool and backwards? So is that possible, or is it like feasible?
To copy snapshot from NFS to store pool, we will need additional conversion.
All right, because it's different type of storage.
Yeah, because in NFS it's a QCAL image, store pool uses raw block devices.
Yeah. So yeah, not directly, but you can do it with some conversion, I guess.
With some conversion, yeah, we can use it.
Cool. All right, questions in the room?